Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 1 paper from summer 2023. This paper is worth 120 marks in total, and this is the 6th video of 6. It will focus on questions 22 to 25, which account for 22 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way that some mathematical skills can be applied. Okay, let's get started. Question 22. So we've got a diagram at the top there. It's not drawn to scale, so obviously we need to remember we can't measure anything directly from it. And then we've got some information in the question. So O to A equals A. So this is a vectors question. O to A equals A. So we're travelling in the direction from O to A, and we're going to label that as A. O to B. So O to B is B. So that whole journey from O to B in the direction of the arrow is positive B. C is the point on AB such that AC to AB is 1 to 4. Okay, so AC to AB is 1 to 4. So the ratio of AC to that whole length, AB, is 1 to 4. So A to C is 1/4 of AB. So we just need to remember that fact. D is the midpoint of OB. So D is halfway across OB. Well, if the whole of OB is B, then O to D must be a half B, and then D to B must be a half B. So I'm just labelling things on the diagram that might help me a little bit later. So they want us to find DC in terms of A to B. So we want to go from D to C. So we've got to follow the journey of D to C. Wonderful. So if I want to go from D to C, I'm going to go D to O. Doesn't matter which way. You could have gone that way if you wanted, but I'm going to go this way. I've got more information labelled on my diagram to go this way around than I have this way. There's a big gap there. I could probably work with it and figure it out, but also I've got this information already, so I'm going to use it. So I'm going to go from D to C. I'm going to go D to O, O to A, and then A to C. Okay, what do I already know? D to O, it's going in the opposite direction to the arrow, so it's the negative a half B. O to A is A, so that would be plus A. And then A to C is 1/4 of A to B. Now, the only thing I don't know in this to simplify for DC is A to B. So let's plot that journey A to B. So if I'm going from A to B, let's go A to O, A to O, and then O to B, because I know information about that journey. So A to O is going in the opposite direction of the arrow, so that would be negative A, and then O to B is going in the correct direction, the same direction, so that would be positive B. So A to B is negative A plus B. So let's pop that in here. So DC is negative a half B plus A plus 1/4 of AB, which is negative A plus B. So let's give us something to work with here. So negative a half B plus A minus 1/4 A plus 1/4 B. So now we're going to collect like terms to get DC in terms of A and B. So we have our A's here. So we've got A, so a whole one subtract a quarter. So we've got a whole one subtract a quarter. So we're going to have 3/4 A left. When we're dealing with our B's, we've got minus a half B plus 1/4 B. Okay, so minus a half B plus 1/4 B. Well, we'll start with minus half, which is minus 2/4. So minus 2/4 plus 1/4 is going to be minus 1/4. So that's minus 1/4 B. And then I'm going to simplify this in its simplest form. So I'm going to factorise. I'm going to pull out a factor of 1/4, which would leave me with 3A subtract B inside. Question 23. So we've got a graph at the top of the page there. The diagram shows a velocity time graph for the first 10 minutes of a cyclist's journey. The velocity is given in meters per minute and the time is given in minutes. So velocity in meters per minute, time in minutes. How many minutes after the start of the journey did the cyclist first travel at a velocity of 9 kilometers per hour? Now, what I would do is I would read that information from the graph that they're given us nice and easily, but unfortunately, our graph is in meters per minute and they're asking us for kilometers per hour. So I'm going to have to convert that 9 kilometers per hour into meters per minute. Okay, so there are 1,000 meters in 1 kilometer and there are 60 minutes in 1 hour. So I've just popped my conversion comparison for meters and kilometers and minutes and hours there just to remind myself. So the first thing I'm going to do, I'm going to start with this 9 kilometers per hour. I'm going to times it by 1,000 because I want to convert it into meters because I want to be working with meters. So 9,000 meters. Okay, now I need to go from hours to minutes. So I'm going to divide by 60. So divide by 60. So 9,000 divided by 60. Well, 60 into 90 is 1. Remainder 30. 60 into 300 is 5. No remainder, so that's 150. So it's 150 meters per minute. All right, now I can read that information from my graph because it's in meters per minute. And I can read straight from my graph. So I'm going to find my pencil just in case I make a mistake. So I want to go to 150 meters per minute, guys. So up here, velocity meters per minute. Okay, and I'm going to draw a line. Now what you will notice is if you continue drawing that line, it will cut through 2 parts on the curve. Don't worry about that because it just wants to know how many minutes after the start the cyclist first travelled at a velocity of 9 kilometers per hour. So they did it more than once, but we're just interested in this first point here, okay? That first point of intersection. And then I'm going to carry my line down and then I'm going to read across the scale. So from 7 to 8 is 5 squares, so it's 0.2 per square. So that's 7, that's 7.2. So it was 7.2 minutes after the start that they first travelled at a velocity of 9 kilometers per hour. Question 24a. Solve the equation 5x squared subtract 8x subtract 1 equals 0. Then it asks that we give our answer in this form where m and n are integers. So that's a big clue as to how I'm going to solve this. Instinctively, usually I try and factorise quadratics to solve them because I find that a simpler method. However, because it wants my answer in this form, this is an exact form that involves some kind of surd, I'm not going to get that from factorising. I'm actually not going to be able to factorise and get integer values. So this tells me I either need to complete the square or use the quadratic formula, because both of those will give me exact forms, okay, for this answer. I'm going to go with the quadratic formula. It's on the formula sheet at the front of the exam paper as well, guys, but you could go with whichever method you are most comfortable with. So the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac, and that is all over 2a. So when I look at this equation here in the form ax squared plus bx plus c, well, a is 5, b is minus a, and c is minus 1. So they're the a, b, and c values that we're going to substitute into our quadratic formula. So minus b, so minus minus a, everyone makes a mistake with that, guys, so be really careful. It's the opposite sign to what b is, that's saying. So it's the negative b. So if b is negative 8, then it's going to be positive when I write it inside here. And then negative 8 squared minus 4 times a times c, all square rooted, all over 2 times a, which is 2 times 5. So we're going to simplify this a little bit. So we've got 8 plus or minus, negative 8 squared is 64, And then we're subtracting 4 times 5, which is 20. 20 times minus 1, which is minus 20. That's still inside our square root sign, guys. It's really easy to make a mistake with this, so it's best to do it step by step like I am, just to be careful and accurate with your calculations. 2 times 5 on the denominator is 10. So we're going to simplify even further. So we've got 8 plus or minus the square root of 64 minus 20, so that becomes plus 20 over 10. Which becomes 8 plus or minus the square root of 64 plus 20, which is 84 over 10. Now, I want to simplify this as much as possible. Now, I know that I can simplify the third root 84. So, root 84, that's the worst square root sign I've ever written. I do apologise. Is the same as 4 times 21, which is 2 root 21. So we have 8 plus or minus 2 root 21 all over 10. Now I can simplify this further. I'm aiming for it to be over 5. And the reason why simplifying root 84 helps is I've now got 8, a coefficient of 2 and 10 that are all even numbers that can be divided by 2. And when I divide them all by 2, I'm going to get 5 on the bottom, which is what we're looking for. I couldn't divide them all by 2 if they weren't all integers, all even numbers and divisible by 2. So just be aware of that, guys. So 8 divided by 2 is 4, plus or minus 2 divided by 2 is 1. So root 21 all over 5, okay? So this is our final answer. M and N are both integers. Okay, part B, use factorisation to solve the following equation. So it's telling us we're going to factorise, but we need to rearrange and manipulate this a little bit because we want to factorise it. It needs to be in a better form than that. It needs to be a little bit less messy. So the first thing I'm going to do is I'm going to multiply both sides by x subtract 1 to eliminate this fraction on the left-hand side. So 4 equals 3 times x subtract 1 plus 2 times x subtract 1 over x. Now I'm going to multiply by x to eliminate this fraction. So I'm going to multiply by x. So this left-hand side is 4x. When I multiply this by x, I'm just going to write it as a coefficient in front of the bracket here. And then when I multiply the fraction by x, it eliminates the x on the denominator for me. Remembering that we had to multiply everything here, 3 and 2 over x by x minus 1. And here we had to multiply everything by the x that wasn't included in the fraction as well. That's a mistake that people tend to make. Now we're going to just simplify things a little bit. So 3x times x is 3x squared. 3x times negative 1 is negative 3x. 2 times x and then 2 times negative 1. So if I want to factorise this, I need a quadratic that's nice and simplified and is equal to 0. So I'm going to simplify the right-hand side first. So 3x squared minus 3x plus 2x. That leaves me with negative 1x minus 2. Minus 2, I don't know why I said plus 2. Apologies. Now I need it to be equal to 0. So I'm going to have to subtract that 4x. So that becomes 0. So 3x squared minus x subtract another 4x is minus 5x. Subtract 2. Now it's equal to 0. We're going to factorise. So because the coefficient of x squared is a prime number, I know the only way I can make x squared by expanding 3x squared by expanding brackets is 3x multiplied by x. And now I need two numbers that will multiply to give me negative 2, add to give me negative 5, but whichever number goes here is going to get tripled. It's going to get multiplied by 3, so I need to be careful with that. Well, there's only one pair of numbers that's going to make 2 when I multiply them, 1 and 2, okay? One of them needs to be negative because I want a negative 2 when I multiply them. So this is where I need to be careful. So I'm going to put my 2 there and my 1 here. I'm going to put a plus 1, I'm going to put a minus 2 because 3 times minus 2 is negative 6 plus 1 is negative 5. So I now have two numbers that multiply to give me negative 2, but when expanded, add to give me negative 5. So we're solving by factorising. So this is equal to 0. So we're going to make each bracket equal to 0 and we're going to solve for x. So we've got negative 1/3 there. and x equals 2 here. So there are two solutions. Question 25. The following probabilities are given for events A and B. So the probability of A is 0.3, the probability of A union B is 0.7, and the probability of A intersection B is 0.1. So in terms of set notation, A union B means it's anything that's in A or it's also in set B, okay? A intersection B is anything that's in A and in B, so anything that they've got in common. And part A says, by drawing a Venn diagram or otherwise, find the value of probability of B. I'm going to use a Venn diagram because I like diagrams to sort information. So I'm going to draw a Venn diagram and I'm going to say that that's set A and that's set B. So I'm going to start here, A intersection B. So that's the probability that an element is in set A and in set B. So that's the middle part of my Venn diagram there. So I'm going to fill that in, guys, okay? And then I'm going to use this piece of information. So it says that the probability that an element is in set A is 0.3. So the probability of it being in this circle A is 0.3. Well, I already have 0.1 taken care of. So if I subtract that, the rest of the A circle must be 0.2. Now I'm going to work with this piece of information here. So this is the probability of A union B, okay? So this is probability that it's in A or it's in B or it's in both, okay? So it's in A or it's in B. So that total probability should be 0.7. Well, I have two pieces of information already. So 0.7 subtract 0.2 subtract 0.1. So that's 0.7 subtract 0.3. So that is 0.4. Okay? So 0.4 is the bit that's missing there. Okay? At this point, I'm going to go back to the question. It wants the probability that something is in set B. So it's this probability here. Okay, it's the full circle. So the probability that we're in set B is 0.1 plus 0.4, which is 0.5. Okay, part B. Find the probability that it's in the set A complement intersection B complement. So that symbol there is the complement. So that means it's not in A. B complement means it's not in set B, and this set notation here is the union. So we're looking for the probability that it's not in set A, or it's not in set B, or it's not in both. So let's think about how that would look as a diagram. Okay, so I'm going to do a little bit of sketching here. So if this is our Venn diagram, we've got A and B. For it to not be in A, it would be everything that isn't included in the A circle. Okay? So that would be A complement. B complement is everything not in B. So it would be all of this information there. Okay? So this wants the probability that it's not in A or it's not in B. Okay? So we want to see what the overlap would be. Now, the only part that is not shaded in both of those things is that middle part of the diagram, okay? Because when it's not B, this is not included. When it's not A, this is not included. So the only part that's actually not included is that middle part, that intersection part, okay? So we need to take that intersection part away and it will tell us this probability. Now, probabilities add to 1. So probabilities add to 1, but if I take away that intersection of 0.1, then this probability must be 0.9, because the only thing that they don't have included in A complement and B complement that matches is that middle point, so we need to take it away from this whole probability.